Hey, IBAASL2, I'm back. Bet you thought the video was over. Well, you were wrong. We are doing a couple more examples to finish off this section. These are from 13.4, if you guys want to see them in the book. So, the first one, a particle moves on a horizontal line. Oh, I should say that right off the bat, this is a non-calculator question, so you guys should not be touching your graphing calculator for this one. Particle moving on a horizontal line, classic kinematics. The displacement is given by this equation here, 4 minus 2 sine of 2t. Now, we're going to find the velocity and acceleration first. So remember that velocity is the derivative of displacement. So, to take the derivative of this, it's a chain rule because there's an inside function. So that's the derivative of the outside. So the derivative of sine would be cosine, but then times the derivative. So like derivative of the outside with the inside untouched times the derivative of the inside. Oh, I forgot the -2 on the outside. Let's just get rid of all that. -2, derivative of the outside. Pull it together, Jolly, come on. Cosine of 2t, but then times the derivative of the inside. So that is -4 cosine 2t. Then they want me to find acceleration. So acceleration would be the derivative of velocity. So if I take the derivative of this, it's another chain rule, and we do derivative of the outside. So derivative of cosine would be a negative sine with the inside untouched times the derivative of the inside. So this is 8 sine 2t. So there we got our velocity and our acceleration. Find the particle's initial displacement, velocity, and acceleration. So that's feeding 0 into all of these. So the first one, S of 0 is 4 minus 2 sine 2 times 0, which the sine of 0 is 0, so this whole thing is just 4. The initial velocity is putting a 0 in for t, so we get cosine 2 times 0. Now the cosine of 0 is just 1, so this is -4 meters per second. So does that mean it was moving to the left at first? I think it does. Acceleration would be 8 sine 2 times 0. So that whole thing is just 0. So this is 0 meters per second squared. This next part says find when the particle is at rest, moving to the right or left during 0 to pi. So we need to set the velocity equal to 0 to figure out when a particle is at rest. So we say 0 is equal to -4 cosine 2t. Divide both sides by -4. We get 0 is equal to cosine 2t. Now we need to figure out where cosine is at 0 on the unit circle. That would be when there's a really skinny triangle up top and a really skinny triangle on the bottom. So that's pi over 2 and 3 pi over 2. Now, this inside 2t is equal to pi over 2 and 3 pi over 2. So if you say 2t is equal to pi over 2 and 2t is equal to 3 pi over 2, we get pi over 4 and 3 pi over 4. So that's when the particle's at rest. Now we need to know when it's moving to the left or to the right. Now, do I need to do a Sine diagram for this? Because I know the velocity was negative in the beginning. Yeah, let's just do a Sine diagram just to be good. it changes at pi over 4 and 3 pi over 4. So if we put pi over 4 right here and 3 pi over 4 right here, and then we plug things into the velocity equation, which is -4 cosine 2t. Like if you plug a 0 into that, you get a negative number. So here in this zone, it's negative. Then it's positive. Then it's negative again. So it's moving to the left from 0. So left 0 to pi over 4. And then it's moving to the right from pi over 4 to 3. Sorry. It's moving to the left 0 to pi over 4 and again at 3 pi over 4 to pi. And it's moving to the right in between pi over 4 and 3 pi over 4. So like all of this is the answer to that question. It's at rest at pi over 4 and 3 pi over 4. It's going to the left from 0 to pi over 4 and 3 pi over 4 to pi. It's moving right from pi over 4 to 3 pi over 4. Part D, find the displacement from time 0 seconds to time pi seconds. So remember, to find displacement, we need to integrate velocity from 0 to pi. So velocity was -4 cosine 2t dt. Now, to be able to integrate this, we've got to do a little backwards chain rule. It's like a mini u substitution, I guess is how you could think of it. Yeah. So, the integral, so the -4 can just hang out on the outside. So this is -4, the coefficient. Integral of cosine is sine. And then we'll do 2t, but then there also needs to be a little 1/2 out in front because the derivative of the inside is 2, and there's no 2 present in it. So, yeah, we'll multiply by 1/2. The other way is you could split the 4 into 2 and 2, but whatever, I've come this far. So this is from pi to 0. So this whole thing, yeah, I guess we could keep the -4 on the outside. Let's do it below. We'll do 1/2 sine 2 pi minus 1/2 sine 2 times 0. Now sine of 2 pi is 0 and sine of 0 is 0. So yeah, this whole thing is just 0. Take away 0. So the whole thing is 0. 0 meters. The displacement of the particle after pi seconds is 0 meters. So that means that it like doubled back on itself. It got back to its starting point after pi seconds. So it didn't go anywhere. It's right back at the beginning. All right, that's it for that problem. Last example, a particle moves along a straight line with a velocity. Oh, so they're giving us velocity at time t seconds. So here's velocity, 4 sine t cosine squared t. This one we can use calculator for part of it, but I'm going to show you guys when it's appropriate and when it's not. So when t is equal to 0, the displacement s of the particle from fixed origin is 5. That's basically like a coordinate of data about the s of t equation, meaning that if you put in a 0, you get out of 5. Find an expression for s in terms of t. Well, if you're going to find s, you have to do an integration of v. So we'll take the velocity equation and we're going to integrate this. It's a reverse chain rule. So So it's forced, you need to think of it like this, that it's cosine t squared dt. So then u is equal to cosine t, and du equals negative sine? Is that right? Yeah. Negative sine t dt. Now in the integral, I see that there's no negative. So when we integrate this, the 4 is going to have to come on the outside when we rewrite it in terms of u. So it's going to be a negative because of this negative right here. 4 integral u squared du. I think that's right. So then when we integrate, we get negative 4, and then we prop it up 1, so 1/3 u to the third plus c. So this whole thing, when you put cosine back into it, is negative 4/3 cosine cubed t plus c. Now, that's the general equation for, what we just found is s of t, the displacement. But we need to figure out what the c value is based off this. When time is 0, it's 5 meters away from the origin. So what we can do is set it equal to 5 and then feed in a 0. So we get negative 4/3 cosine cubed of 0 plus c. Now, cosine at 0, if you think about the unit circle, is at positive 1. So cosine cubed also is at positive 1. So this equals 5 equals negative 4/3 plus c. Add 4/3 to both sides, and we get 19/3. So that means s of t is negative 4/3 cosine cubed t plus 19/3. This next part says find a of t. Well, to find a of t, we need to take the derivative of velocity. So v prime of, here, let's write v of t first. So velocity equals 4 sine t multiplied with cosine squared t. Wait a minute, is that like a double product formula? Let me check the book. Oh, it's just like we're going to have to do a product within a product. Gross. Okay, so you need to think of this last part here as parentheses cosine t squared. So that doesn't look like a C. There we go. Okay, so a of t is going to be the derivative of that. Derivative with the product rule is first t second plus second t first. So first, and then d second. That d second is a chain rule, which means we do derivative of the outside, pop the 2 out in front with the inside the same, times the derivative of the inside, and derivative of the inside is negative sine. So that was first d second plus second d first. So second is just cosine squared t, and then d first is going to be cosine t. Nice. So when we simplify all this, like here I see a sine and a sine, so that'll bump it up to sine squared. But then there's a negative and a 2 and a 4. So this whole thing is negative 8 sine squared t cosine t. Yeah. Plus, really the cosine's just not, cosine squared with cosine is cosine cubed. So you get 4 cosine cubed t. Awesome. That's that whole part. So that's a of t. That's the acceleration. Now, find acceleration, velocity, and speed of the particle at t is equal to 6. So if I move this up here, we're going to have to do s of 6. So the s was negative 4/3 cosine cubed of 6 plus 19 over 3. This is the part where it's okay to grab that calculator. That you can't really do this by hand. But you're just putting 6. Oh, it doesn't ask for, sorry. I thought it said displacement after 6. Oh no, I lost the t and velocity or the y. It wants acceleration and velocity. So we'll have to do a of 6 is equal to negative 8 sine squared 6 cosine 6 plus 4 cosine cubed 6. And this whole thing should equal 2.94 meters per second squared. Velocity of 6 is going to be 4 sine of 6 plus cosine of 6 squared, which is negative 1.03 meters per second. And then they want the speed. Remember that speed is just the absolute value of velocity. So no, they don't use s, they just say speed. Speed equals the absolute value of the velocity at 6, which is 1.03 meters per second. Part D, is the particle speeding up or slowing down at t equals 6? You have to think way back to first semester where I think it's been a while since we've talked about it, but because the acceleration and the velocity are different signs, one's negative and one's positive, that means that it's slowing down. Yeah, so both of those are negative and positive, which means it's slowing down. If they were matching signs, it would mean that they were speeding up, but they are not. Last one, find the displacement of the particle over 0 to 6. Are we doing just displacement? Oh, and distance traveled. Find the displacement and distance traveled. My bad. So we're going to do this one on a calculator. Remember that the displacement is just integrating from 0 to 6 seconds. So we go 0 to 6 seconds, but then we're going to integrate the velocity. So the velocity, I guess I'll put v of t dt, is going to be 0 to 6 on a calculator. Velocity was 4 sine t cosine squared t. dt. And I believe when you punch this into your calculator, you should get 0.153 meters. Now, distance traveled is when you get to use that absolute value trick. And you go 0 to 6 of the absolute value of the velocity. So we'll do 4 sine t cosine squared t absolute value dt. And this equals 5.18 meters. Whew. All right, guys. That's all I got for us. Unless I decide to do a third video after this. Who knows what's going to happen?